Welcome again. Now is time for scientific talk and tech talk. First of all, the first talk is Cloud Computing, Present and Future by Professor Josep Bernabeu Auban, head of the Distributed Systems and Cloud Computing Group of the Computer Science Department of this university. Professor Bernabeu Auban is full professor of this university with a wide experience in the computer industry. Professor Bernabeu Auban holds more than 20 international patents and is the author of many scholarly papers. He also is currently leading the Distributed Systems and Cloud Computing Group within the Computer Science Department in collaboration with the Technological Informatics Institute. We said ET, okay, from the acronym in Spanish. Professor Bernabeu Auban was partner architect at Microsoft Redmond when he was part of the team that incubated Windows Azure, leading the design and first implementation of its automation technology. Previously, Professor Bernabeu Auban acted as a scientific director of ET, remember, Institute of Informatics and Technology, since its creation until 2004, and played key roles in the design of software products and protocols for the Sun clusters products during years 1995 and 97 of last century. Professor Bernabeu Auban obtained his PhD in from the Georgia Institute of Technology after graduating with a master or licenciatura in theoretical physics from the Universitat de Valencia. Current areas of interest of Professor Bernabeu Auban center around the study of distributed systems and algorithms, cloud computing and complex systems networks. With you, Professor Josep Bernabeu Auban. Ahí tens això. Ara te posa la traspa. Quina és? SWERC. Està?
SWERC, PPTX, no, de baix.
De baix.
Okay, thanks, John. Well, today I'm going to talk about cloud computing and the cloud, okay? So what is this about the cloud? The first thing I want to talk about is to clarify maybe what the concept of cloud is. Cloud is a buzzword lately. I mean, you might have heard about it. Everybody talks about the cloud. So the question is what it is. I'm not going to clarify with a precise definition of what the cloud is. What I'm going to do is to do an exposition, and hopefully at the end of this, you will get an idea of what cloud is and what cloud computing is. So where does the word cloud come from? In the 90s, there was all this crazy industry about client-server computing, right? So people drawing diagrams about where clients were and servers were. They used to get hung up on wiring diagrams with networking devices, etc., etc. To simplify all this, they just drew a cloud. So all that mess was hidden under the rug, right, under the cloud. So with the evolution of the usage of networks and the internet, the cloud came to be understood as, well, that media or that medium that gave you access to tons of web pages and applications, right? Applications like shopping or banking, etc. So all those things, by the way, were actually incorporated into the term cloud, not just the network, but also a set of services and computing resources, right? So that's what more or less is understood by the cloud. By the way, the cloud nowadays is not just a set of desktops and the servers which are behind the internet, it's all sorts of devices. I mean, this slide actually pays no justice to the variety of devices which nowadays one understands as being part of that thing called the cloud. You have not just computers, not just laptops or PDAs or telephones. You also have special purpose devices like energy meters, like actuators, etc., etc. All of those things are assumed to be connected to what's understood by the cloud. So associated with the word cloud, right, you have the next buzzword, which is cloud computing. So what's cloud computing? Well, essentially it's distributed computing by some other name under the context of the cloud. So what does cloud computing actually provide you? Essentially, it provides you a set of services delivered to a bunch of devices, right, using, and this is important, some innovative business models, okay? And to understand the evolution of computers and the computer industry, it's not just enough to understand the technology which is behind it. One should also understand what is the business model, the economics, okay? So I would like to just dive a little bit into the economics of the software industry as it has evolved over the years. I think that will illustrate why things are going the way they are, right? And what are the problems we confront. I'm going to borrow some ideas and some way of presenting this from Professor Chu at Stanford. So I think he did a very good job of explaining this. I'm going to borrow that approximation. So you have the traditional business model for software. We all are familiar with this, okay? You have a system vendor. The system vendor spends money, invests in developing some nice product. And how does it actually monetize that product? It sells licenses. So their customers from ISVs, they just pay a lump sum, something like, in this case, by the way, I'm using numbers by paying attention to some kind of applications, like business applications for large companies, because there is data for those kind of applications, right? So I want to pin numbers also so you get an idea on what the costs involved are. Okay, so the traditional model is you have the vendor selling a license, right, to the customer. That license covers unlimited usage of a particular version of that software, okay? Now, if the customer wants to have access to new releases, to bug fixes, and wants to have the right to call the help desk on the ISV, right, on the vendor, it needs to buy a support contract, right? So in that support contract, the numbers you see here are the ones more or less published out there, and it comes to about being 20% of the cost of purchase of the license, okay? And that gives you right, as I said, to new releases, bug fixes, and the right to call them and ask for help if something doesn't work properly, or report bugs so that they get fixed on time. So this kind of business model, when it works, and it has worked very well for many, many different companies, it produces enormous profits for those companies. I mean, I believe it's estimated that 90 to 95% of the revenue of those companies comes from actually of those boxes in there, from the support box, okay? So the money is made here from the support, not from the sale, from selling the licenses. So a variation on this also came up in the 90s, which was all related to open source. Okay? Open source is right now very alive and well. In the 90s, the open source monetization model by those who wanted to actually get something out of the open source movement consisted on, okay, they don't sell you a license anymore, okay? Because the code is open source, so you can actually go ahead and use it right away. But you still have problems of support, okay? You need to have access to a team of people who can actually solve your problems and who you can report bugs and push that product in a certain direction. Now, we have quite a bit successful stories for Model 1, the traditional model, okay? You can think of any of the large software vendors out there. I mean, you can think of Oracle, you can think of Microsoft, you can think of SAP, for instance, to pick up a European vendor. Now, in the open source arena, okay, for some reason, customers didn't see the advantage of paying that support fee. I mean, there is a disadvantage of selling that support, right? I mean, the software is free at the end. So in the closed model, you're paying for releases. In this model, why should you pay more, right? And why should you pay for releases if those are supposed to be free? So it wasn't, apparently, business-wise, it wasn't so sellable. And in fact, I mean, you can find probably the most prominent success story in this model is Red Hat, right? Through the Red Hat network of subscriptions. They also have a very nice business model. It's the same business model, by the way. I mean, it doesn't change the traditional one. It just doesn't charge upfront for the license. But as I told you before, I mean, the business in the model one is in the support. So they try to keep exactly the same business model. Okay. So that's as it concerns the vendors. What happens with the customers? Okay. What's the real cost of the software after all of this? So for customers, the cost of the software is starting with the purchase of the license. And that's not the end of the story. I mean, once a customer buys software, it needs to maintain it. It needs to manage it. It needs to do things, right? So what things are there? So that we get an idea on, I'm going to put a figure later on, and you might be surprised of how much or how large that figure is. So let me tell you what needs to happen for a customer purchasing software, for instance, purchasing Oracle or purchasing SAP. So for starters, they need to do the deployment of that software. And before they do that, they need to do some sort of capacity planning. And this is not just one shot kind of thing. They need to keep on doing this, okay? Because their user base might change. It might grow, it might contract, or they might need to cope with software capacity needs, which might be changing over time. Or they might actually decide to use the software in new ways, which puts more load, and they need more resources or less resources. They also need to take care of something which is not in the slide, but is what happens when failures occur, right? I mean, they cannot stop the business process within the company. So what I'm getting to is they need to have a team of people, right? Team of people means cost to take care of issues related to capacity planning and availability resolution. What other things are there? Okay, security planning. Somebody has to actually decide which functionality of that software is accessible to each one of the users within the company. That's for starters also. So somebody has to come up with a policy, implement it, configure the software so that that policy actually gets reflected on how the software works. On top of that, okay, software is not perfect, we know that, okay? Big software is less perfect. I mean, you are bound to have bugs. Some of those bugs have security impacts, and they need to be applied as quick as possible so that you don't get exposed to the vulnerabilities of those bugs. So all that implies that you need to have more people on top of the people you had before in order to manage this process also. What else is there? Well, I just said software is not perfect. Okay, so there will be other kind of bugs. So maybe it doesn't work as expected. Maybe it doesn't have the performance. So there will always be releases, okay? A release might carry with it an increase, an improvement on the functionality, or it might carry with it an increase of performance, okay? So every time such a release arrives to the company, you have purchased the support, okay? Now you get a new release, release 2. So what happens? So somebody needs to decide what to do with that release. First of all, chances are that you haven't yet finished stabilizing the deployment of the previous version. That might happen. That has a cost. And then you have to decide. And in the decision, you have to consider two kinds of costs. On the one hand, you have to decide whether or not what this new release gives you is worth it, okay? So what are you losing by not installing the new release? That's the cost of opportunity. And if you decide to install it, then you have another cost, which is you need to install it, okay? That's not free. You need to have a team of people which actually can do this installation without disrupting the function of the company. So that has another cost. Okay, and last but not least is customer support internal to the company. Okay, you have this team of people, which are technical people, know how to install the software, know how to do all the other processes we have seen. But your end users, they do not. Okay, a user using SAP or the SAP different workflows, they don't know exactly what's going on with the computer system. They're just end users. And they might encounter problems, so they need customer support. They might have questions like the ones you see there. Usually, customer support is tiered, okay? You have a first tier, which tries to answer the simplest questions, right? You call, and say, oh, come on, I mean, you should switch on your computer first, or something like that, right? So those are cheap to actually pay for. I mean, you have a small cost in that personnel. What that line in there tries to show you is the increase of cost as the issues get more and more complex. Okay? The issues might get complex enough as maybe one of the users inside the customer install base has detected a real problem. So there has to be some higher level people who actually dive in and try to figure out what the problem is and try to fix it. For starters, maybe communicate it to the vendor. Anyways, there are costs. Okay? So if you sum all of this, that constitutes what you might call the total cost of ownership. Okay? It's not just what you pay, it's also what you need to spend to actually make that software that you purchased work in your environment. Now, by some estimates, that total cost of ownership in this kind of companies might run upwards of 4 times the purchase price of the license per user per year. Okay? And that's a considerable amount. That's pretty large. So, considering this, some companies saw the opportunity. Okay? So, what opportunity was that? What is driving this cost? This cost is being driven by the cost of people, of personnel. So, what can you do? You can go to a model where you say, okay, don't spend that on your people. Let me do it. So there are some companies which tell those customers of models 1 and 2, give me the task of managing all that process of getting the software running in your company. That's the outsourcing model. And well, they are essentially like model 1 and 2, technically speaking. And the customers of models 1 or 2, they go through a big process and they get the cheaper one, which gives them enough guarantees that they can actually manage the software process at their companies, at the installation base. And they can do it either at the home of the outsourcer or at the computer center of the customer of the software. So there are those modalities. So the question is, how can they actually reduce the cost? Okay? And by the way, this model was actually pretty popular, or picked up, not popular, it picked up at the end of the 90s. Okay? And the best case, or the best success story for this model is EDS. I mean, EDS is a company that probably you all have heard of. Okay? It's a consulting company. So how could they reduce the price? Well, relatively easy. To reduce the price, you pay less to the technical people involved, and how can you pay less? You go to the places where they cost less. Those places at the end of the 90s were India, East Europe, Asia, etc. Right? So in there, it was estimated that the cost of a technical person was 1/10 of the cost, for instance, in the US. Okay? So that delivered quite a bit of savings. So that's how these people could actually produce a model which resulted in cheaper costs for the customer, for the end customer, and they could make money also. Okay? But the model, technically speaking, was no different from the models 1 or 2. It's the same thing, license plus support. The only thing that it introduced is externalization, okay, of the management of the software deployment. So, can we do better than this? Can it be done any better? Well, as it happens, consulting companies, but also the vendors themselves said, hey, I mean, we know better than anybody how our software works. Okay? We produce it, and by the way, we test it. And to do that, we need to have people who know how to do this over and over and over again. We do it in a standardized way. So we use some particular computers, some particular OSs. But when we do this, we do it many times. We standardize the process. And at the end of the story, we do it so many times, standardize the process so much, that we can write software to do it instead of people. Right? So then you get to a hybrid model in which you still have that pay for license. Okay? You pay for support so that you can get new releases and all that good stuff. But now, these outsourcers, they can give you a much cheaper price. Okay? They can give you a price of, let's say, estimated about $150 per user per month, instead of the almost $1,300 that you had before, right? So that's a big savings. And how can you actually get these big savings? By automating. Keep in mind that in Model 3, you have 2 problems at least. The 2 problems are, one, you have a floor cost, a cost floor, okay? And that cost floor is, okay, I mean, you pay less for those people, but what happens? As time goes by, those people start earning more and more. Their cost structure approximates more the cost structure that you had at the beginning in other places. And besides, you have those people. Okay? You cannot go beyond the cost that it takes you to pay those people to take care of those problems. So the only way you can actually improve is to automate, to make things so that you don't need so many people in order to take care of those problems. So this is a big step between 3 and 4, and this is sort of the core on where is cloud going and what are the problems that cloud computing tries to solve. The problems that it tries to solve and the way it tries to solve them is by automating as much as possible. Okay? So, by the way, I mean, it's easy to go from what appears there as Model 4 to something like Model 5 without charging for that license, without charging for support, and all you charge is for actual management. Okay? Because you automate so much that your costs are small, right? And you can actually pass those savings to your customers and you can have more customers. So the vendor still makes a nice amount of money and it's cheaper for the customer. And all this is all thanks to automation. So what's the next step? Here you see that we still have that the outsourcer can actually do the management at your facilities or at their facilities, okay? So you have that choice. And you have many other choices, like you might actually choose what OS you want, etc., etc. So all those degrees of freedom, what do they go against? They go against automation. They go against automation because you don't have a standard way of doing things. So the next step is to improve on cost by reducing the degree of freedom. And then you get to what is understood as the software as a service model. Okay? In software as a service, you don't have a choice of where management happens. You are told where it happens. You access that service via a network. You don't have it installed locally, necessarily, okay? So, and by the way, you lose other freedoms. Upgrades are not up to you. Somebody decides when they are, okay? And the degree of customization that you have from that software is also greatly reduced. What do you gain with all this? You can automate much more than before, okay? So that's what you get, and you reduce the cost pretty much. You reduce the cost from the company providing the service. We'll see later on an estimate of the cost structure for those companies. But you also reduce the cost, of course, for the end customer. So associated with this model, there is another one, which is very prevalent nowadays, which is, let's call it the internet model, Model 7. So in the internet model, there is nobody charges the end user for using the services. Okay? Monetization is made indirectly. Okay? So success stories, we all know them. Okay? Google is the biggest success story relating to ads. As for transaction, one big success story is Amazon, for instance. Amazon, I remember some years back, they were contending that they were a technology company. And people were saying, well, you're selling books. Well, they were a technology company. I mean, in order to sell books the way they did sell books, they actually deployed a large development organization, okay? And that has paid off for them because they have got into something else. They have been the pioneers of the basis for cloud computing, as we'll see in a moment ago, in a moment. Okay, so I promised you I would show you the cost structure for some of the models, specifically for the models which start making use of heavy automatization. That's from Model 4 to Model 7. And you can see here what that cost structure is. In Model 4.5, cost structure is about $100 per month per user. Okay? You see a decrease in order of magnitude going to Model 6. That's thanks to automatization, to increase in automation. And you see another order of magnitude for Model 7. These are estimates, which I picked up from different sources. Okay? So Model 7, remember, is Google's model. Okay? So their cost per user, they have tons of users, right? Is very, very small. It might be even smaller than this by now, okay? So all this because they automate to the end of it, okay? Okay, so what are the technology enablers for models 6 to 7, which are the interesting ones from the point of view of cloud computing? Well, no great breakthrough, okay? What happened is there were a bunch of different technologies and adoptions of those technologies which matured during the 2000s, during the last decade, essentially. Okay? So first of all, massive availability of communications. I mean, how can you impose an SaaS model unless your users can actually access it with a decent enough bandwidth and a low enough latency. Okay. Then there is this other buzzword, which I've seen around a lot, which is Web 2.0. What's Web 2.0? Well, my take on it is it's just the ability of making it possible to create desktop-like applications via browser. That's Web 2.0. You can have very complex applications delivered to you with zero cost of management on your part. Okay? So those applications just arrive to your browsers. You don't do anything for that, just connect to the page you want to get. So those two things have been technology enablers for 6.7, but they haven't been necessarily the main ones. There is another one. Another one which impacts big time automation, and that technology is virtualization. Okay? So again, virtualization hasn't been invented in the last decade. I mean, it was around in the 90s. However, it matured. Okay? By the mid-2005, 2006, every big company had some sort of solution for virtualization, and there were other solutions which were open source and readily available. Okay? So what does virtualization actually buy you? It buys you the ability to automate even further. I mean, you deal with machines as pieces of data, and you can manipulate them in any way you want. You can move them around. You can set them up very quickly. Okay? So that's a big advantage. That ability was around at the beginning of the 2000 decade. At the end, you could do things like that in the networking spectrum, which gave you even more ability to automate setting up a big service. Okay, so, okay, I didn't fix this slide, it seems. So where are things leading? Things are leading this way, okay? Everything, I'm going to be a bit extreme. Everything is going to be a software as a service. Everything by every application, okay? It's going to be in the extreme a software as a service. There will be cases, of course, which will fall out of this because of the nature of the problem. So which business models will they follow? 6, 7, they are still relevant. X, and I will talk about X in a minute. Okay, a mixture of 6, 7, and X, we'll see. So we have also software which runs on client devices. Some of that software, at least, will need to be managed from the SaaS. Okay, that's happening already. And what's not happening so strongly already is maybe the devices will also be managed by the SaaS themselves. This makes lots of sense in enterprise environments, if you think about it. It also makes sense, for instance, I mentioned before, energy meters, okay? Whoever sets up the energy meter wants to manage the full device. All right. So, what's wrong with this picture? This seems very nice. However, how does a small company start providing a successful SaaS service? Okay? It seems like the investment cost might be prohibitive. Okay? It might need to set up a data center or pay up front for renting the resources of a data center. So this is where a key innovation plays a big role. Okay? And that key innovation is, on the one hand, maturation of technical properties. I mean, compute as a service, storage as a service, networking as a service, as I mentioned. But the most important innovation is from the business point of view, the pay-as-you-go innovation, okay, that business model. Before we saw in SaaS that the business model required, let's say, a subscription per year. So that's a commitment. You pay something whether you use it, whether you don't use it. Typically, you pay more if you use it more, but that's not part fully of that model. With this model, you only pay if you use, and you have no commitment. Okay? And when you join those two innovations, what you get is something called an infrastructure as a service. All right? So essentially, what you can do is you can access some service out there, and instantly, almost instantly, you can loan a bunch of different computers, network, storage, etc. Okay? So Amazon was the leader in this space. So that bookseller was the leader on this. Why was it the leader? Because it developed internally the company, and it sells things, as they say. So why not selling also computing resources? And that's what they do. They impose this business, and they are successful with it. Yeah? They are making money out of it. Initially, it wasn't clear whether or not they were making money or whether the model was viable. I mean, they are making money with it, and the proof that this is a viable model is that many more companies have jumped in later than them. Okay? Microsoft is one of them, but not the only one. Okay, so let's look at what scenarios are enabled by an infrastructure as a service. Okay? Things that before they were technically possible, but not really doable because of the economics. So gradual scaling, the grow as you need, more resources scenario has been enabled by the business model of IaaS. Why? You don't have to commit to a big capital investment in resources in order to start your software as a service, okay? You can start small. You can have a few amount of resources, pay only for those resources, and if you need more resources, you can instantly, take this with a grain of salt. You can very quickly react to that increase of demand, okay? This wasn't possible before. I mean, before, if you wanted to increase your capacity, you need to do purchasing, or you need to go to a data center and agree with a contract, etc. Right now, it's just a connection to a web page, and you get instantly another computer, if that's what you need, or you need more storage, if that's what you need. Okay, so what does this mean? Anybody can produce the next successful SaaS, right? The barrier of entry has suddenly dropped. Anybody can get in, okay? There is a wider playing ground and a wider competition area. This is good. This is good for everybody, for us users and for us developers, right? There are inconveniences if you have a playing ground which is flat because you have more competition, but think about it. I mean, now the small fish can actually get in the action. Before it was much more difficult. You needed capital, much more. Okay, so what other scenario is enabled that before was expensive? High volume occasional needs, okay? So, for instance, you need to run an experiment, okay? That's occasional, you don't have periodicity for this. You need to run, let's say, a performance load of a SaaS that you're actually developing. And in order to do that performance load, you need to recruit thousands of different computers which actually go and try to use that SaaS that you have set up. And you want to observe how it behaves, if it behaves properly under load, okay? So now you can do it. You can just recruit those resources, use them for a limited amount of time, pay a small amount of money, and you're done. You get your results. Before you couldn't actually do this very easily. Okay, then this one is another typical scenario enabled by the IaaS business model, which is periodic high volume runs, okay? And there are many, many different instances of this. I'm just showing two. The first one, okay, medical biology, this is an important area. Medical biology, as you might know, is becoming more and more an information technology area, right? You just run some lab work, you get a bunch of data, and then you process the data in order to extract conclusions, okay? So some of the things that you can do, for instance, is to try to do some cancer diagnostics, okay? To do that cancer diagnostics, you need to build some heuristic models, right? And once you have those heuristic models, you can have quick algorithms that, given a piece of data, like an analysis of DNA or proteins, it can give you an answer on the likelihood that somebody might actually be developing a particular kind of cancer, okay? Now, building those heuristic models, that's an expensive proposition, okay? You need to actually feed the learning algorithm with a bunch of data, right? And you don't need to do it every day, but you need to have that data collected, and periodically you can set up yourself to periodically run those learning algorithms and build your heuristic, okay? And once you have that heuristic built, then you're in business. You can continue providing that service. All right, so that's just one case, which I thought it's interesting. The other one is a more down-to-earth kind of problem, payroll. Who would think about payroll? Payroll, well, people who are involved in this, they say it's a complex problem. It must be, but because of all the variations and complexities of the law. However, there is one characteristic of it which makes it quite nicer for the cloud, right? It runs really in volume only once a month, and quite predictably, okay? So you don't need to have a big data center to actually outsource the payroll for a bunch of your customers. You can rely on the cloud. You don't have to invest on that data center, and you pay only for that amount of time that you use the computers to actually get the results for payroll, okay? So you could actually save money big time if you went this route, okay? So where does all this lead at the end? So at the end, this leads to a connected world where SaaSs actually provide services to all sorts of devices. Okay? Now, this picture, you might see it around as labeled as the Internet of Things, which is another buzzword, which essentially is pointing you back to cloud computing, because the Internet of Things without cloud computing cannot be put in place, okay? And what it refers to is everything which has a cord, a power cord, has also a network cord, right? And that network cord has to be used for something, to communicate with some sort of service which extracts data and can perform actions which are interesting, okay? So that's the whole. Very nice, that's a rosy picture. Now, how can we actually do that? Because we haven't finished with the costs involved in software. So we have the traditional IP. You manage everything, okay? You manage networking, storage, servers, blah, 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 right? So the customer that purchases software is its own service provider, right? And as its own service provider, it has to manage all those things. We talked about them. With the introduction of an IaaS model, the nice thing about it is you don't have to worry about managing networking, storage, service virtualization, and some part of the OS, but you still have to manage the rest. Okay? You as your service provider, you are providing a SaaS. You need to care about all the things up there. Okay? Caring about those to provide a SaaS, such that the users of that SaaS don't care about any of that, has a cost. Okay? You need to care about things. What things are those? Okay. First of all, let's look at what a cloud service is, a SaaS. A cloud service is nothing else than a distributed system, okay? And a distributed system, what is it? That's the result of executing a distributed application, fine. And what is that at the end? That's a bunch of different components. Some of them are replicated, others not, okay? Replication, you know, might be the result of reasoning that we need more fault tolerance or that we need more capacity to actually be able to deal with a higher load. And, well, there is a factor in an SaaS. It has to be externally accessed, okay? And that external access comes with strings attached, okay? And those strings attached is some expectation of what is the performance expected, okay? And under the name performance, really, a more technical term is the quality of service. What quality of service expectations are behind that service? Because if that service is up only 1 day a week, maybe that doesn't meet my quality of service expectations. For instance, to just name one measure of quality of service, which is availability, general availability. So, this SaaS needs to be managed somehow. The question is how and at what cost, okay? So what are the problems? To start, again, deployment and configuration. We need to set up this service, okay? That means somebody has to put in place all those things. We are in the cloud, okay? We have rented a bunch of different computers. We have set up networking for it, but they need to be put in place. They need to be put in place and configured. And all of that with what goal? The goal is I want to satisfy a certain quality of service. So that's the constraint. It's not just as simple as that. I mean, I need a quality of service. I am open for the public everywhere, right? And I need to make sure that I can satisfy that quality of service I committed to. By the way, it's likely that I will depend on other services too. I mean, I'm not going to implement everything from zero, right? So I will need to depend on others. Depending on others means that I need to take into account what is the quality of service those others actually can commit to me, because that will impact the quality of service I will be able to give to my customers, okay? So that's one source of complexity which will translate itself into cost also. Failure handling, we have a distributed system, okay? We would like the cloud and the cloud IaaS services to be so nice as to never fail the instances that they provide us. That's not one guarantee they are ready to make. They cannot make it, okay? So we should expect failures to occur. When a failure occurs, we might have a compromise in the quality of service. So something needs to be done, okay? What needs to be done? Fix the failure, go back to normal, go back to be able to guarantee quality of service yet again. Okay, so load variations. This is a biggie in cloud computing. We should be able to adapt to load variations, to scale out, right, or to scale in, depending on how the orientation of those load variations is. So we might start with just say one device accessing the service, right? Now what happens if suddenly we have 1,000 different devices? Well, If we don't change anything in the service, we might have trouble with the quality of service we are ready to actually provide. Okay? So something needs to intervene. The service needs to be managed, and something, for instance, a new instance of the front end, in this case, in this example, needs to be introduced to be able to take up the load, introduced by those extra devices using the service. Okay? And then we might go back to a normal quality of service. Okay, so upgrades. We have a problem of upgrades. I mean, as before, as in any model, software is not static. Software changes. Software for real-world applications, it keeps on changing. Okay? So what that means is that you will be confronted, given a service, with introducing those upgrades. Okay? Be them for fixing bugs, for fixing security, for fixing anything, or be them to introduce new functionality. Okay? So you need to take care of that. So what's the problem here? This has gone too fast, right? So the problem here is that while you are upgrading, you might actually impact the quality of service. You might, in the worst case, you might actually take the service down. By the way, that's the easiest strategy for upgrading. Take the service down, take it up. If you do that, you are certainly impacting the quality of service, right? So can you do better? Can you arrange things so that the service is still up and running while you're performing that upgrade? Okay, and also, finally, the aspect of connected device management. You have connected devices, right? Those devices have software, okay? That software needs to be managed somehow. Either that software or the device itself, in the most complex case. How is that done? Okay? How do you build an SaaS application so that you can actually get to this point, okay? Reliably, under upgrades, okay? With failures, whatever, okay? So, the summary of what needs to be taken care of is all this. And the running theme is decisions seem to be driven by the commitment to guarantee a certain quality of service. If you take quality of service out, the problems still exist, but they don't seem so important. You can take the service down, you can fix whatever it is you need to fix, and then you can take it up again, and everybody's happy. So there is another term, which is service level agreement, which tries to capture the quality of service agreement. Okay? The commitment to quality of service. The service level agreement, in general, is like a contract between the users of a service and the service itself. Okay? The service commits to a certain quality of service if their customers commit to behaving properly, right? And ask the right things from the service. So that's what a service level agreement. So we are driving everything, we are driving the cost by the need to maintain a service level agreement on our services. So back to the picture we used to have. All those things we need to do, they drive that cost arrow we draw. So the question is, what can we do to reduce this cost? What have we done until now? Automate. Okay? So can we actually automate all those things in the cloud? Well, the answer might be, right, still to be proven, something which people understand nowadays as a platform as a service, a PaaS. Okay? So a platform as a service actually takes care of all that management, and the ideal PaaS lives in the hands of the vendor only generating the application. Okay? The vendor, the developer, they concentrate only in the logic of the application. All the other aspects, they are left to the PaaS. Okay? That's the ideal for the PaaS. Okay, so essentially you have a PaaS, you have an application that you want to convert into a service, you're the service provider, ideally you package that application somehow, okay? You send it to the PaaS, and the PaaS generates a service and manages it, okay? That's the ideal function of a PaaS. Okay, all of that, by the way, the PaaS and the service it creates stays in what we are calling the cloud. Okay, so what needs to be resolved? And in this slide, I try to put, to emphasize and underline the issues which are not resolved, okay? The issues which are open and open for research, okay? So the way to actually automate even further is to standardize further, okay? To constrain how things are done. Okay? That's the standard path to automate. To automate, you need to know what to expect. And to need to know what to expect, you have to constrain. So essentially, as a PaaS has to provide SaaS developers with what's understood as a service model. And what's a service model? Is essentially a set of guidelines and constraints providing something like that. The software developed for that service model has to follow a set of strict patterns for component intercommunication. You cannot just come up with any network of connections between your components. You have to follow some strict rules. Why? Because for those strict rules, my automation engine will know what to do. If you give me something different, I won't know what to do. Okay? So the PaaS has also to have a way for the SaaS provider to specify what is the SLA, okay? Or what are the SLAs it can commit to. So there needs to be some sort of SLA formal language so that you can actually tell the automation engine, this is my goal for performance. This is my goal for quality of service. And that performance engine can actually go ahead and make it happen, okay? By whatever algorithms. Okay, the language is nice, but then you must have a way to relate that language with actual resources given to the service. Okay, so you need to have a way of mapping. You have to have a way of actually coming up with a mapping of the specification to a model of how the service works, so that automatic actions can be taken for you. Otherwise, what is the PaaS going to do if it doesn't know how adding an instance of any particular server impacts the performance? Okay? Well, together with this, the service model will also have to provide, or has to provide, with guidelines to write software. Okay? Now, we are in a distributed system. Okay? That means that you're going to have failures. It's fine if something that manages your service recovers one of the instances that failed, but your software better be ready to confront that situation, because you might observe the failure. Okay? Trying to hide this and make it transparent to you is much too expensive, right? So you might actually not scale if you expect the PaaS to make it fully transparent to you. So what needs to happen is for you to write that software following some rules so that it can stand those failures without actually falling on its face and failing completely, okay? Now, related to this, you also need to write the software so that you can actually fit particular patterns of upgrading the service. Upgrading the service, if you think about it closely, is introducing failures, okay? Because every time you're changing the software or something, you are or either taking it down, right? Or you're setting up a new server someplace else with the new software and taking down the old one. So you're somehow introducing failures. So you better be ready to enter some sort of protocol, of procedure, so that you can be upgraded without being taken down. So in exchange of doing all this, in exchange of you writing your software adhering to a particular service model, what do you get? Well, what you get is all the advantages we talked about a moment ago. All those managing cores, they are taken care of by the PaaS for you. Okay? Now, if your problem fits what the service model of a particular PaaS gives you, right, you're golden. Follow that model, and you will have a nice way of quickly creating a software as a service, right, which is self-managed. It's managed by somebody. You don't have to spend on more personnel to manage that service. And that's a big boon for you and your customers if you pass that advantage to your customers. All right, so that's the next challenge in cloud computing, providing PaaS which actually fit the expectations I just talked about, which are capable of automating everything but writing the software. I mean, somebody has to write the logic of the software, fortunately for all of us. You know, everything else which is not what you want to do, which is not the service you want to provide, right? Somebody else do it. Because at the end of the day, you think about it, they are repetitive tasks. Okay? Somebody has to look, monitor whether or not that has had a failure and then recover. Somebody has to put forward an upgrade. I mean, yeah, it's interesting to actually come up with the procedure to do it, but do it once, twice, over and over again, that's not that interesting. So if we can automate that, the better. Let's concentrate just on the algorithms. Let's concentrate just on the functionality of the software. That's the goal. Okay? We are not there yet. We're not there yet, but there are a bunch of companies jumping into this space, large and small. Okay? There are the large ones, the usual suspects are there. I hope I didn't forget any. I'm sure I forgot some. But then there is a bunch of companies I'm sure you never heard of in your life, okay? That's normal. I mean, remember what I said a moment ago. The playing ground has been leveled, okay? Almost anybody can get in the action. You need some capital, of course. You need to have availability of people who do the programming, of course. But you don't need to invest in capital goods. You don't need to do that. You don't need to commit any more expenses, right, beyond the ones you minimally need, which is somebody doing the programming, okay? So what is to be expected moving forward? Well, you see these many companies. There are many which are not. In this slide, there will be more moving forward. In the coming years, there will be what I call PaaS wars. And the wars more similar or most similar to these ones I'm talking about here are the ones that happened in the past, in the 90s probably, still going on but less, among different operating systems. At the end of the day, if you look at what a PaaS is trying to do, it's trying to do what an operating system tries to do and more, okay? Now, once a developer of an SaaS decides to go for a particular pass, okay, they are actually committing to the APIs and the environment of that pass. So they are stuck with that pass, unless they invest more for developing, okay, and changing environments. Same thing as it happened years back between, let's say, Windows and Unixes of various kinds, or between the operating systems of other vendors, okay? Once you did an application for those vendors, you were stuck with those vendors, okay? It costed you to move somewhere else. So similar things are going to happen here. I mean, all those companies are going to fight for developers, all of them. They want developers to go to them, okay? Now, I'm not claiming that any of them actually have a pass which fulfills what I said before, okay? All those bold-faced letters, etc., they were pointing out open issues. They haven't been closed. The issue of how to maintain automatically a given SLA, right, that hasn't been closed at all, okay? Starting from SLA languages which are actually workable, right? Following with relating the SLA that you specify with how that impacts the actual resources that you need to run your service. That is not solved, okay? None of them actually are providing the full set of benefits that a PaaS should provide. However, some of them will come up with good approximations as we move on. So, this is all I had prepared. As you see, I have tried not to be enormously technical. I don't think it was the right setting to actually delve into a particular problem. But I tried to give an overall perspective on what cloud computing is, why it is important, and what are the open problems which are still on the table, available for anybody to jump in and try to solve them. Okay? So thanks for your patience. By the way, if you have any questions, I will be happy to try to answer them.
First of all, thank you very much for a very interesting talk. I would like to have your comment. Well, I would like to ask you, but I won't, because I think you have a compromise with probably some of these approaches. Where should I bet my money? So in the end, we all know that when a new technology arrives, many companies try to put their position, set their position on the market, but then only a few succeed. So, but probably this is not a polite question to make to you. So I would do another one instead. I guess that
you can make that question. I mean, I don't mind.
Okay.
I can answer you with okay. I don't know.
Okay, it's a good one. Anyway, I think most people will ask you another thing. Probably I would like not to be stuck with none. So I would like to have some level of abstraction so that I could develop my software and still be able to deploy it to whatever provider that. Okay. So are people doing anything in that
Okay.
in that path?
I can answer you that. So first of all, that's a nice goal for developers and service providers. That's not a good goal for PaaS providers, right? I mean, what interest does Microsoft in making your life easier if you want to move your application from Windows to Linux? None, okay? Now, if you think about macOS, same thing. Do they have any interest in making your life easy to move your application from macOS X to Windows? None at all. Why, right? That's not their platform. They don't make any money if you do that. Well, you could take the second derivative of it and say, well, if your application is more popular, blah, 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 maybe they make some money. But the usual approach is no. Okay, I was in a conversation with the people from NIST, which were trying to come up with a standardization for a PaaS. Well, they were in the wrong place. They were in the place of a would-be vendor of a PaaS. Okay? So the answer they got is the natural answer at the stage in which we are right now. I mean, nobody is thinking about standardizing the APIs for a PaaS. Nobody. Okay? For a very good reason. Because those are platforms. Platforms are very, very sticky. Okay? And they want to stick you. They want you to stay with them. Everybody, every one of those. When they produce a platform, they will want you to be with them. So what's the difference between this and an IaaS? An IaaS, sorry, I mean, I still have difficulty with these names. The difference is they provide you, how should I call you? A very standardized product. I mean, they provide you machines, storage, communications. So all of the vendors, they have different APIs, but they are similar in functionality. So in Equality, you have a standard out there, I don't remember the name. And you have a standard API, which is easily mappable to all those vendors of IaaS. So for those vendors, right, you can have your software. For instance, if you're doing a PaaS, you can have your PaaS, which attacks that standardized API, and then you can deploy it anywhere on any of those vendors. However, I predict that for that to happen on PaaS, that will be a long time. It's not, as I see it, in the business interest of any of the potential vendors for PaaS. They want you to stay with them. Once you go there, they want you to take care of you and get your money, if possible, right? So the answer is, I don't see it. Okay? It might happen because things move much faster now than years back, right? So this was my resolve earlier. And by the way, I think you also were asking this question. I am not putting my money necessarily on the big names in there, right? You don't know. I mean, those big names operate in mysterious ways whenever they want to develop new technology. I mean, they are big, humongous beasts, and they take time and, you know, fights, internal fights, in order to move the company in a certain direction. So it's not guaranteed that even them having the resources, they're going to be the ones coming up with the best technical solution. If you look at the history of many of these companies, they have moved forward and progressed by purchasing other companies, which provided them with people and technology. So I don't know which one is the best bet because it's quite complex, right? What I can tell you is that it's not a given that IBM or Amazon or Microsoft or Oracle, right, or Google will come up with the right solution or with the solution which sticks better in the market. Who knows? At this stage, I think it's too early. Everybody's moving. That's the only truth.
I wanted to ask you, as this is a PaaS war, in some future there will be a winner. So there will be a standard PaaS provider. I think like for OSs it came out Windows. Maybe Oracle will win this war. And will it come to a scenario in which all the data of the world will be stored in a big Oracle data center, maybe? Is this really secure to put all our data into the hands of someone at the head of Oracle?
Well, you're asking a couple of questions there. One of them I think is related to the one that was asked before here. Yeah, I mean, there are going to be fights between the PaaS, similar to the OS fights. I'm not sure that there will be just one winner. Probably not. I mean, if I have to predict anything today, no. There will be more than one, okay? That's for sure. Because as this thing progresses, each one of the solutions will gain their own customers, okay? And they will stick to that if it doesn't cost them, okay? So the logic is you'll have several. One of them will be the winner, there will be a second one, same thing as in every other aspect. Now, as for security, well, all the data is going to be in the cloud. I don't know that one. Okay? Now, certainly recent events told us that it's not that secure, data moving through the networks which are open. Okay? Some people have access to that data when they shouldn't. So is that solvable? Well, the short answer, if I have to give one today, is no. Because at the end of the day, if you have to use that data to be processed in the cloud, you're giving the keys of your house to somebody. I mean, that data has to be in the clear in a machine you don't control directly. So that guy in the cloud, if it wants, it can get to your data while it is processed at the least, right? You can encrypt it, right, in the store. You can send it encrypted there, but if you want to process it in the cloud, right, your resources in the cloud will need to have it decrypted. So while that is happening, whoever controls those machines can access the data. So that's a vulnerability. So is that going to happen? Is there going to be laws that are going to forbid that? Even to governments? I don't know. This is not a technology issue. This is a policy issue. I don't know. So the short answer is, technically, you cannot ensure that your data is secure in the cloud, especially if you want to process it in the cloud. If you want to process it locally, you can make it quite secure with standard techniques. But if you want to process it in the cloud, all bets are off. You're opening yourself, right? As for the other question you had, is all the data going to be in the cloud? I don't think so. Okay? There will always be interests which will not care about putting some data in the cloud because of these reasons. I mean, one of the things is you don't know what vulnerability some technology you use to protect your data has, right? So, and you don't want to discover it because that data has gone to the public. So physical security has always been a good way to protect something. So you might not want to let it out of your data center if that information is really sensitive. Okay,
Is it the trend to use some few open standards, so in this way we can move service from one vendor to another and maybe keep inside the service, or any vendor tend to use another format, so in this way I cannot move very quickly data and other things?
Yeah. So this is another variation, I believe, of the questions that have been asked. My take is vendors themselves, right, they will try to have their own API. It's to their own interest. Now that API, they'll have to think about it. There's API plus services. They need to think about it so that they form an attractive bundle, so they can actually call you, developer, and develop under their umbrella, right? But they will try to differentiate themselves from the competitors. That's only natural. They'll try to provide you with a different product, if they can, okay? So I don't see standardization playing a big role for the time being. It has played a role with IaaS, but those are commodities, almost. You know, computing, storage, etc. Those are commodity resources. It happens that most of the providers have used very similar approaches. So it can be done there. With PaaS, let's say, what do? You have a different, you can come up as another company which tries to unify the whole forest of proposals which are out there. That happened also with OSs, right? When there were several OSs people had to choose from, there was a period of time in which you found adapting libraries, so that you could actually program against those adapting libraries, and without you seeing it, those libraries could actually work against Windows or Unix or any variety of the Unixes out there. You could expect to find something like that also in the cloud. But when is that going to happen? I don't know. And what reason should anybody have to actually propose that model? I'm not so sure either. Okay? So what I see is, for the time being, and for a few years at least, a variety of offers. And by the way, the nice picture I presented a moment ago, nobody's offering it yet. Okay? Nobody has solved those problems. So there is plenty of space to innovate.
Well, thank you very much, Professor Bernabeu.
Thanks to you.